Yes, you may. We've already factored some polynomials. What polynomials have we factored incessantly? What kind of trinomials? Quadratics. We factored quadratics every which way but up. And then we did up. Y'all are not entertained today. Calculus wouldn't talk to me today either. Everybody's just ready for break, I think. All right. We're going to practice. We got factoring practice. Good work. All right, let's review back some ways that we factor, specifically some special patterns we taught, because I think everybody remembers how to group, do you? Okay, let's do that first then. If I had something like this. No, that's just a blob. How would I factor that? So it's what multiplies to 6x squared, but adds to negative 5x. So what are the two terms? Negative 3x and negative 2x. And so then I'd throw those two in here, and I'd have 2x squared minus 3x minus 2x plus 3. And now what do I do? You slash it. That's exactly right. Slice, slash, whatever. Get close to Halloween, we'll slice it. You can take out x, and what's left? 2x minus 3. And then what can I take out of the last two? Nothing. So I just hold the place with a 1, right? And because that middle sign is subtraction, I changed the last sign. So 2x minus 3. Now finish it up. What goes in front? Either x minus 1 or 2x minus 3. It doesn't matter. But now it's fully factored, right? Do we all remember that? Oh, yeah. So anytime I see 4 terms, I automatically want to go to factoring, because it could start out like this. It could maybe start out like this. What if it looks like this to start with and I said factor? It's no longer a quadratic, it's a polynomial, right? It's a cubic polynomial. But any ideas what I could do here? Slash it. Try to slash it. See if it'll slash. If I try to slash it, what can you take out of the first two? R squared. What's left? 4r minus 3. The middle sign stays. What can I take out of those last two? Nothing. So I hold the place with what? 1. And what's left? 4r minus 3. And so now I have 4r minus 3. Now what do you notice? I did post it. I thought, did I not? Don't worry. What do you notice about what's left here? What do you notice about these two pieces is what I'm getting at. Anybody see anything special? Got to rewind back to unit 1. Okay, so what do you notice about that? You're on the right track. Keep going with the r squared piece. There's an exponent inside of there. It's r squared, so it's definitely a quadratic. Not yet. Yes, Harris. Nobody? Let me sidetrack over here for just a second. What's special about this? Nothing? Think factor what? 4 is a perfect square, x squared is a perfect square. What happens if you have two perfect squares in the factoring world? You can write it as this. The difference of two squares. Y'all, I'm not losing my mind. We've done this, right? Okay. Okay, so yes. So here's what we're doing. As we go through factoring, since we're factoring polynomials, not just quadratics, we have to check all the parentheses to see if we can factor them anymore, okay? So always put a note wherever you're taking your notes. Always check parentheses to factor further. Okay, this is what we call factoring completely. When we check every single parenthesis and see, can we do anything again, that's factoring completely. So 4r minus 3, can I do anything else with that? No. So I leave that. How about r squared minus 1? I can factor it further because now it's a difference of two squares. How does that factor? R minus 1, keep going. Close, plus 1. Now it's factored completely. You see how we broke that up? Even after we factored it, we broke it up further. All right, so there's your recap on your, well, we got one more special pattern. Do you remember what it was? You're right. Who said it? Who said dancing? Gracie, look at you. Square dancing. That's right. If it's square dances. Those are perfect square trinomials, right? That's what y'all got this. Again, remember, we're still in review from Unit 1. I told you Unit 1 will haunt you for the rest of your life. It never goes away. Perfect. There you go. This is the square dance. If the ends are perfect squares, what has to happen in the middle? They have to, the product of the square roots doubled has to give you what's in the middle. That's exactly right. So what would go in the middle here to make this a perfect square trinomial? Close. Square, square, multiply, and double. What goes in the middle? 12x, right? This could be a plus or minus, it doesn't matter. But that first sign will tell us what the sign inside the factor is going to be. So how would this factor? X, first sign, square root. It's the square root. So remember, this is where, remember when we completed the square and we found a good C and we put it on both sides and we factored and we solved? That's where this is coming from, okay? And since we're factoring polynomials and a quadratic is a polynomial, this will still come up in our stuff, okay? This is you. Gina, you okay? What's wrong? Your hair looks pretty today. All right, ready for the new ones? Let's do quadratic form first. Not formula, quadratic form, okay? So, I have this polynomial. And in fact, let's take that same one we started just to make life easier. Thank you, whoever did that. Was that Harrison? All right, so you have to, even though this is a trinomial, it's not a quadratic anymore, right? How do you know it's not a quadratic? It's a quartic. Nice, good job. So, but it is in quadratic form. You remember how a quadratic looks? It's ax squared plus bx plus c. If it's similar to that this way, we call it quadratic form. So here's what has to happen in quadratic form. The first exponent is even. The middle exponent is half of that first exponent. And the last term is a constant. Okay? Evens half constant. If you have that set up, you can factor it the same exact way you factor a quadratic trinomial. Okay? Multiply the first and the last together. We look for a GCF first, but multiply the first and last together. What do you get? 6x to the 4th. What multiplies to 6x to the 4th but adds to negative 5x squared? Negative 2, but you got to have the variables on here. X squared and negative 3x squared. Do they add to what's in the middle? Yes, because they're like terms. If you multiply them together, do you get 6x to the 4th? Yes, because when you multiply same base, what do you do with the exponent? Add them, right? And 2 plus 2 is 4. Everybody see where those two terms came from? How it is. So now I'm going to fill it in just like I did with a regular old quadratic. 2x to the 4th minus 2x squared minus 3x squared plus 3. That's right. Slice. Not just 2x, but 2x squared. That's exactly right. 2x squared, what's left when you take that out? X squared minus 1. I got this middle sign here. What can you take out of the last? And what's left? Close. I got to change that last sign since that middle was a minus, right? So now finish factoring that. Are you done? You can do it again, right? You got x squared minus 1 is a difference of 2 squares, so I can break it down one more time, right? So this one I can't, right? 2 and 3 are not perfect squares, so I just leave that as is. But that x squared minus 1, there you go. Perfect. What do you think about quadratic form? It's really not anything new other than the exponent. That's exactly right. You okay? Let's do the good stuff then. Last thing for today. No, because they're not perfect squares. So this is what I would say is factored completely, because I look at each set of parentheses and I can't factor any of them any further. Hey, y'all have time to do your homework today. No, 24. Well, that was half of it. It's actually 20. All right, now, the hardest part, too, about this is keeping this straight with the squares. This is a special pattern. You know how we talked about perfect square trinomials and difference of two squares and how their patterns you just have to memorize? That is what this is. So, here we go. Notice this is sum or difference. If it's squares, it only works when it's what? Do I have a sum of two squares? No. Do I have a difference of two squares? Yes. If it's cubes, I can have a sum or difference. Can you imagine why? Because it's odd. And if you take an odd root or you multiply a number an odd number of times, it keeps that sign, right? But with square roots, I'm restricted to only positive. But here, there's no restriction. So that's why I can do sum or difference. All right. I think I just showed you. If you have two, and I'm going to run, they're the exact same pattern, but I'll run two different examples here. Here's the sum, and here's the difference. Bless you. So you're going to have to be able to recognize perfect cubes. Numbers like 1, 8, what's the next one? 27, 64, that's exactly right. about the next one? There you go. There you go. You found your list, didn't you? Okay. We need to be able to recognize these numbers because that's going to clue us in that we're in a sum or difference of cubes type situation. Okay. All right. If you see yourself in this situation, here's what you do. I always set up my parentheses first. We're going to do little parenthesis, big parenthesis. I'm going to draw a line here to see. Little parenthesis, big parenthesis. Okay. Do your signs first. Your signs are going to be same, change. This is going to be a binomial times a trinomial. And the last sign is always plus no matter what. Okay? Same thing if it's different. Same, change, plus. All right. We'll figure out for the first parenthesis. What times itself 3 times gives you this number? A. What times itself 3 times gives you this number? Now I'm going to use this to form this trinomial. Close. I'm going to take the first one and square it in the first spot. And I'm going to take the second one and square it in the last spot. And then for the middle, I'm going to multiply them together. No, multiply the first parentheses together. Just these two together. You're always using that direct. It looks a lot like a perfect square trinomial, but it's not doubled. Okay? Just AB. The pattern is going to be exactly the same for the second parentheses. For this other pattern. And again, this is something you just have to get used to doing, to memorizing, okay? All right, let's do an example of what it looks like, because that's just in general. Now remember, these can be plus or minus. Squares have to be just what? Minus. Yes. It's same, change, plus every time. So in my factoring process, remember I'm always looking for a GCF first. Does this have a GCF? That's okay. No, right? There's no GCF here. So the next thing I want to look is I want to look and see, does this follow any pattern? Yeah, what's the pattern? They're both perfect cubes, right? Everybody sees that? What times itself 3 times gives you 64x cubed? Smaller. 4x, right? 4x times 4x times 4x will be 64x cubed. What times itself 3 times gives you 125? 5. So they're both cubes, so I'm going to set up little parenthesis, big parenthesis. What are my signs going to look like inside? Plus, minus, plus. Same, change, plus. Now, what did you tell me? I always write it right under it like this so I can keep it straight. What did you tell me multiplies by itself 3 times to give you that? 4x. What did you tell me multiplies 5? Now, I'm going to use these pieces to fill in what's missing over here. If I square this, what do I get? 16x squared. That's exactly right. If I square this, what do I get? 25. That goes on the end. They always stay on the ends. Then if I put them together, That's it. It is literally just a pattern to plug into. These things are not ever going to factor any further for you. If you get yourself to a sum or difference of two cubes, once you do that, you can just stop. You will get to some later on that'll factor further, but for right now, they're not going to factor any further than that. So that's the answer. Would you still understand it if I put variables in here? Factor that completely. I'm going to give you a second. Try it on your own, and then we'll do it together. You don't have any like terms right now. Couldn't name one. All right, tell me what your first step is to factor. Look for what? GCF. Is there a GCF? X, y squared, someone said. I agree. If you take out xy squared, what's left? X6 minus, what do you notice about x to the 6th minus 1? Do it 6 times, I heard. 1's a perfect everything, so I have to determine what x to the 6th is. What is it? Perfect square, perfect cube. Is it either one? It's both. It's actually both. Why? What is the definition? What's the definition of a perfect square? Times itself twice. What's the definition of a perfect cube? Bless you. What times itself twice gives you x to the 6th? X cubed, x cubed. What times itself 3 times gives you x cubed? X squared, x squared. Right. Right. I would if it was me, pick the cubes because that's probably going to factor us the furthest. It's going to give us the best information for what we're doing. That's what I would do. So if I set this up for cubes, keep that GCF on the outside. Little parenthesis, big parenthesis, yes? Now you try it. I'm going to stop here now that I've led you in the right direction a little bit. How many of you got that? Yeah? I see no's and yeses. No, it's not wrong. What times itself 3 times gives you x to the 6th? What times itself 3 times gives you 1? Then we use those numbers to fill in the second parentheses. What is x squared squared? It's 1 squared. What is x squared times 1? but I'm not done. That's just the GCF. I just took that out and it'll just keep following the problem down. Huh? It is in quadratic form, but it won't factor any further for you because nothing multiplies to 1 but adds to 1. But true, that's a great observation because it is. I can. That very first parentheses is a difference of 2 squares, so I could do xy squared. I could break this one down again. And then I still have this one, and it is in quadratic form, but I can't factor it any further for you. So that's the answer. And now it's factored completely. This is one of those things that